And we're live. All right. Good morning, everybody. Welcome back to the dive stream. I see some viewers are hopping in. Welcome. This is a live view from the science camera of ROV, remotely operated vehicle Sebastian. Not to be confused with Dr. Sebastian Watt, our chief scientist of this expedition. We have just touched down on a sandy bottom in a channel a little bit north of the Yelcho Delta. So we're in a new location today. And I'll switch the camera view just for a second. We have landed pretty much on a school of fish, which is quite exciting. Quite a lot of life here. And despite all this life surrounding us, we're still going to be moving forward with our geological sampling. So right now we're going to be doing some push cores. We're going to be doing some Vibra cores later as well. And our lovely scientists in the room are going to be explaining that whole process and what they're hoping to find. But we are continuing on with our fire and ice volcanic and glacial interactions expedition. We're pretty much a little bit over halfway, so we've done a lot of cores. There's been a lot of action in the labs processing those cores, so it's been really exciting so far. And this morning we got a beautiful sunrise over the town of Chaiten, so that was also wonderful. And with me here in the room today, I've got Zach and Andy as our pilots this morning. Oh, fishy. And behind me, I've got Josh, one of our marine technicians. He's been making sure our data streams and navigational data is looking top-notch. And of course, I've got an entire
school fish. And I think we've seen these before on previous dives, but not in these numbers. And my guess would be that they're sort of shoaling here because of the river system that we're just offshore. So we're actually quite a bit deeper than we were yesterday. We're at about 170 meters water depth, and there's a sharp drop off the platform where we had yesterday's dive. So for any of you who watched yesterday's dive, you'll have seen that it was very murky, turbid water, very little that we could see at all. That was on the margin of a steep bank, south of which is a channel. And this channel is fed by a river system called the Yelcho River, which is a pretty large river for this region of Chile. It moves up from the south and from the east. And offshore this river, there's a deep water channel, which we think probably is a route for much of that sediment coming out of the river system. So we come into this channel to understand the material that's moving along it at the base of the channel. And also to understand if this is also a route for material from the Chaiten volcanic eruption. So last night we were on this platform and we recovered cores, and there's evidence of ash even in those very shallow push cores actually. So potentially, or quite likely even, the 2008 event reaching the margin of this bank. So we're interested here to understand if that was then routed, or at least some of that sediment was then routed through this channel towards the south. We've just got one ROV dive to do it, so we selected this site as what we think will be a representative point. So, are we on the push course?
Yeah, we're waiting to see.
Just waiting for it to be clear a bit. Yeah. There's clear, as you can see, that there's large shoals of fish which we haven't really seen in the environments we've been in so far. So it's an interesting observation to see how life is varying over quite small areas. So we're starting with the push cores next, just waiting for things to clear a bit. You're maybe just starting to get a view of the seabed. It appears not quite as muddy as it has been at previous sites. We didn't kick up quite as much fine material when we landed, but nevertheless there is some fine material which has been kicked up by the ROV landing here. So we're just waiting for some of that to settle out and the currents to pull it through. Now the currents here are actually really quite strong, interestingly in the sort of middle of the water column, so they're not particularly strong at the surface. But as we were coming this channel, which again I think must be linked to this constriction, this submarine constriction, and the interaction between the river and the tides, with water sort of rushing back and forth with the tidal cycle. So perhaps that's also an explanation for the distinct fauna that we're seeing here. So getting pretty clear, nice views of these fish now, and I think we can see the seabed fairly clearly as well. So we're going to start off, when the pilots are happy to do so, with the first of the push cores. You can see the empty space on the rack for that one, the red one. And we're just going to move through collecting 5 of these at this site. Diego, I assume you want scoop bags at this site as well? You don't think so?
No.
Okay, in that case we'll just do 3 push cores. You sure?
3?
Yeah. Do you want any at all, just to get a representative sample?
Any juice?
Any grabs?
No.
Okay. Now, so for those who perhaps haven't joined these previous dives, or haven't heard the commentary on previous dives, I'll just talk a bit more about why we're here during this project. Apologies if this is some repetition for those of you who've joined several of these. I know there's a few people who've been to a lot of our dives on this cruise, which is really, really great to have you joining us. And hopefully you're getting sort of an interesting insight into what we're doing in the range of sites. But where we are in the world is offshore northern Patagonia, in the south of Chile. This is a pretty cold environment at this time of year, so when we go outside it's pretty chilly. It's been cloudy for most of the past 2 weeks, but this morning we had beautiful views over the mountains, so we could see a glaciated volcano in the sort of near distance, a volcano called Mincha Mojida. And then beyond that we could see the higher peaks of the Andes behind, which is the first time we've been able to see those peaks in the whole of the last couple of weeks. So it's nice to have a clear morning. So this is an environment in which we have ice-capped mountains, steep forested slopes. So we're very near shore actually on this site, just off this river system, and we can see these steep slopes plunging down into the sea, covered in dense forest. It's a sparsely populated region. There's not a lot of lights when you look out at night, but we are near the main settlement in this area, which is a small town called Chaiten. And Chaiten sits of, this group of rivers really, but in particular it sits at the mouth of a river called the Blanco, and 3 different rivers actually converge in this very slightly distinct drainage basins. But the River Blanco is the one we're really interested in, and then it erupted in 2008 without recognised warning, with a large explosive eruption. And this was a dramatic and very significant event in this region of Chile. And it was an eruption that was of interest to volcanologists all around the world, in terms of magma fragments. This is driven by the gas content of the magma, and it's linked to the viscosity of the magma, so how stiff that magma is when it is flowing. And in very viscous magmas, bubbles in that magma are inhibited from expanding, and they can't coalesce, so you tend to get a magma with a lot of small pressurized bubbles as it descends towards the surface. And this is an effective way in an explosive event to produce very large volumes of fine particles, what we call volcanic ash. Those particles can mix with the atmosphere, they exit the volcano at high velocity. As they mix with the atmosphere, they exchange heat with the air they're mixing with, and they ascend up into the atmosphere until they reach a level of buoyancy. So this sort of plume of ash and hot gas is less dense than the surrounding atmosphere, so it rises upwards in what we call an eruption column. And these can ascend to 20 kilometers or more into the atmosphere. So the Chaiten eruption column and the plume that then fed ascended around 21 kilometers into the atmosphere. So that's a lot higher than the mountain peaks here, which are at the highest around perhaps 2 kilometers. So this injects that mixture of volcanic particles and gas into the atmosphere, and then those particles are transported by wind. the level of the atmosphere they reach is called the stratosphere. So the Chaiten eruption caused ashfall over a huge area of Argentina, and that's actually when I first studied that event, was mapping out those deposits in Argentina. Now those deposits get thicker and coarser as you approach the volcano, the bigger ones. So these lahars are slurries of volcanic sediment and water, and they can be transported by water derived from things like snowmelt, from crater lakes, but also from rainfall mixing with this sediment. So the risk of lahars was recognised at Chaiten, and indeed they occurred within, how many is that? Is that 3?
That's it.
We can stop at 3. Yeah, thank you. So straight to vibe recording.
Are we going to go in without vibrating like yesterday?
I think it. Yeah, I think at gentle vibration it may be a bit firmer. It doesn't look quite as soft.
Okay, so start out with vibration?
Yes, please. Yeah, just sort of low level, and let's see how much resistance there is. So the risk of lahars coming down through Chaiten town was recognised because this river system was draining the volcano and because this is a wet climate. And the entire town was evacuated within a couple of days of the eruption. I need to look at the exact timescale actually, but it was a very rapid decision. And that was a timely decision because within 4 or 5 days, heavy rainfall had caused lahars to come down these river systems, and they caused extensive damage. They also caused change. All this sediment is funneled through the river systems. So the Blanco river system received an extreme volume of sediment compared to its typical behaviour. That sediment moves rapidly when the river gradient is steep, but when the gradient declines, which is what happens at the mouth of a river, that water can no longer transport all that sediment load, and it also slows in terms of its velocity, and so it sort of exceeds the capacity of the channel, and therefore it spills out over the channel. This is exactly what happened in Chaiten town. The river in fact cut an entirely new channel right through the central part of the town, and the flows, these slurries of water and volcanic sediment, spread out through the town. And indeed, when they reached the coastline, they deposited a lot of that material and rapidly built out a very large delta, extending the coast by around 1.5 kilometres. So this was, in a sort of matter of days, a really transformational change in the area around Chaiten. And this has been well studied as an example of understanding lahar processes, in terms of understanding rhyolitic eruptions and ash deposition. But what has not been studied is what the impact is of these lahars in marine environments. Now, the marine environment in this region is important. The main access to Chaiten from the north is via, in fact the only access really, is via ferry routes. There are many island communities who for which Chaiten is the sort of main local town, and of course fisheries are an important part of the economy in this region, and so on. And in many places, sort of marine offshore infrastructure as well is also potentially vulnerable to these sorts of processes. So we're sort of interested for a range of reasons in understanding the impacts of events like this. And in particular here, it is unlikely that the 2008 eruption is the only time that lahar generating processes have happened in the sort of more distant past of the 2008 event at Chaiten, but understanding if we can use the marine sedimentary record to piece together a picture of past events as well. So every time there's this sort of large explosive eruption, we would expect to have an event that flushed all this sediment into the marine environment. And we can then go and explore and understand the archives of those events. Now that's potentially a longer term project because the cores we're collecting here are relatively short, but they at least will help us understand if there's the potential to obtain deeper records, and if there is that potential, where we should target those core locations. Not the end of our research in this region. Indeed, it might be the start of longer term projects to address further research questions. So we've still got plenty of fish here, and hopefully that gave a bit of a background as to the work we're doing here. We've moved from the push cores, we collected 3 of those, onto the Vibra core, Push cores allow us to recover around 20 centimetres or so of sediment at the seafloor interface. This is valuable to really get a very clear indication of current environment. But the Vibra cores allow. So we just see that first Vibra core going in further now.
Is this a 2 meter?
Yes, 2 meters. Okay.
Yeah, I just read your message.
Okay.
So, you're saying that after this we do the gravity?
No, well, if you want to.
It could be, but it's kind of
Last
too
night.
soon.
Yeah.
Because if John wants to talk to me, probably he wants to go over the safety procedure and all that, they're gonna take that
That's
couple
90%
of hours.
place that it will be on a RV set. So that was the only reason.
Oh, you mean in this very side?
No, no,
In some
not
other side?
In an RV site.
Yeah, yeah. Well,
Just because we're near stuff, but we don't. It
Oh,
doesn't
okay.
have to be.
Okay.
Only if you're.
let me check on that. But the problem I have is that if John wants to meet with me, that's gonna take me some time to talk to the crew.
Yeah.
Probably they would want to go out there. And I was planning on just assemble the thing with Ivan and some other person.
Yeah.
So if they want to get involved, that's another hour, I guess.
Yeah, yeah.
So it's gonna be like 2 hours probably to get the whole thing prepared.
I think the first decision is there a suitable site
Nearby.
nearby that you can so the two ROV sites to the north, I think, are the only ones probably. There was one in the low backscatter facies, struck by segments, and then one at the northern margin of the delta, which is where we saw the grey actually lay.
Right.
But I still want to check them on the SPP to see
Yeah, yeah, yeah,
they
yeah.
really are suitable.
Yeah, I don't think in this. I don't think in the bay right there it's gonna work.
Okay.
Mostly because we don't know exactly what it underneath.
No.
The fine
Yeah,
sand.
we're going through fine
Gonna be-
sediment, but we don't necessarily know
No.
what's beneath that.
Exactly.
Yeah.
Uh,
Yeah, it's got to be.
I was
It's got to be only if
thinking-
you're
I was
happy.
thinking try the first one maybe in a more distal location, so
Okay.
we know it might be
Okay.
just to try the first time,
Yeah.
and then can get more.
So the other
more-
option is the basin that the far west basin. Which is our,
Right.
We've had one ROV site in basin west. It's the one that's rich in forams.
Right there.
No volcanic material that you can see there, but it probably is suitable as an environment. So that would
The,
be.
the,
we-
the one
we
you
could go
mean the
there.
one where Becky found like forum solar
Yeah.
undercourt?
Yeah. That's it's basically directly west of here. It's not so far.
Yeah.
And
And
we
you're
could do
saying the
that
one with
later
the,
in the day.
with the
potentially.
two ash layers is up north.
Just like this.
Yeah.
Remember the station number?
4. Already 4.
And the one that Becky found in front? I asked him.
14.
Yeah, I think it was
14.
something around.
Yeah.
All right, I'm open it.
Yeah.
There was another one with just one beautiful layer.
Yeah, that's the one in the bay on the north side as well. It's not far from here. Not far from here.
Coming down?
Yeah. If you can get me a map, then we can
Well,
look. But I don't want
I just talked to Ivan. I talked to also Claudia.
Yeah.
Talked to Paula.
Yeah.
Last night we went really late with Matilde because after the meeting we came
Yeah,
to the
yeah.
geophysical. Talked to Paula and so started working on filtering the bathymetry.
Yeah.
Last one, and it comes out now.
Matilde fixed the code, the one that she mentioned.
Yes. Yeah.
And,
So I,
Yeah, but
I think
let-
it's probably worth having that discussion with John, so it's at least ready for when when you're ready.
Yeah. Okay.
Yeah. I've asked Alistair to get all the core locations, but if
Well, that's the thing.
yeah, if you have a map, I can point to you the ones that's, and I've asked Senai to get the sub-bottom.
Okay, so you can grab it whenever you're ready.
Question about this side.
How much recovery was that? About a meter and a half?
The major issue, I think, is with the
So I'm
Blanco
gonna try and rank out.
the ROV sits like that in the water, so your pings. Who?
Oh.
Why?
Yeah, so there's something wrong with the core cut here.
That's interesting. We're getting an insight into to what we're recovering, but
Yeah,
that
yeah,
core
yeah.
catcher's not closed.
You
is
guys
it?
notice that?
Any ideas? I guess we try another one.
Maybe this is a different. You know, these are all the
The modified.
ones that we've been using.
Yeah, that might not be a good idea.
I mean, yeah, let's try another one. if nothing else, we could also scoop some of that sediment that's been falling out. Certainly looks like we're getting sunny sand here, right? Grey sand.
So we're gonna go for another one, right?
Please, yeah. With the mud on the outside. Yeah.
Why does it have mud? This is all sand.
Maybe
So
that's
there's
just
not all
sand at the base.
Well,
Perhaps. Let's try another one. I've not seen
no,
that.
That's a weird thing because that's half the course, so it's about the meter. So we got, a lot of.
Yeah, there's mud well down it.
Yeah. It's strange because remember the size of the dunes here? They were quite large.
Later in the day. And then we've just seen something a little puzzling in terms of
Can you guys look at that?
losing sediment from the Vibra core, and actually you can see it in the foreground there, this grey sediment, quite pale grey sediment. So clearly we've gone into something distinctive and something rather different from the mud that we can see at the seabed. But we really want to recover that material, so it's concerning if it's falling out, and quite a volume seemed to slip back out of the Vibra core there. There's a device at the base of the Vibra core called a core catcher, which is designed to prevent that material falling back once the core's been inserted. This one performs, and if we see a similar issue. Zach,
Yeah.
if you pulled it out and closed the gate and left it in situ, like when you were recovering the Vibra core, if you lifted it up but then just closed the gate,
Yeah, like we've been doing when we're done.
yeah, that would create less of an issue, right?
Yeah, I mean, it wouldn't have anywhere to go then.
Yeah.
So, yeah.
So we
If
could
this
try
is the
that.
last one, we can do that.
Yeah.
Are we only doing 2 here?
Well, maybe not. If we've lost so much of the first one, I'd like to know if we get a similar issue first.
But yeah, that last one, we can do that.
If it doesn't work, maybe
Let's
shift the location.
pull it. Once we need to move up the course first to get a different hole. A couple of meters. But yeah, I think let's lift it, see if we're seeing the same issue with fall down.
Yeah, that should tell us if it's something unique to that catcher.
That's a challenge though, isn't it? Because we can't necessarily predict the type of sediment until we get to the site.
Although, I don't know, I could be totally wrong, but my gut tells me honestly that the fingers that we had originally would have worked too. If we could just,
Yeah.
it was more just what kind of sediment.
Okay. Okay.
Or not, but that's just a guess. Okay.
So could we move slightly? Just
Yep.
a couple of meters, please.
Yep, the head, doesn't really matter where.
Doesn't really matter. In fact, yeah, tiny distance is fine, because we could even potentially try to scoop some of that sediment we lost. Would be quite helpful to know what it is.
The strange thing is that the site we showed was supposed to be on top of one of the dunes.
Yeah, but this is potentially quite thin mud.
But that's I don't get, because in theory you are on top. Most of it should be sand.
It should, but if those dunes were shaped in,
Look at
in
how much more.
in an event or a period. I mean, this is what we saw yesterday, is those big dune patches, but they were drained with thickness, so they're not active today.
Yeah, I know. But still, dunes are dunes.
Yeah.
Shouldn't have any of this.
Well, but if they
This is what we
formed for a period when the current was stronger, it is. I mean, the bottom current today is pretty weak.
Yeah.
The strong current higher up in the column.
The thing is, if it's not too strong, then you don't have dunes.
But what I mean is it must have been strong in the past, at some point, or linked to some.
Yeah, but if it is
Yeah.
strong, then you don't get mud. If it's not too strong, then you don't have dunes.
Yeah, so they can't have, what I'm saying is they can't be
Really
continued.
can't tell,
They have been strong.
A lot, yeah.
They may not be strong now.
We need to figure that out.
Yeah.
Okay, I think it's clouds. I'm starting to see some features that aren't.
Random comment, those fish kind of, they will be good on the grill. No, seriously. I'm getting
Plenty of them.
Yeah.
Okay, yeah, we're
This, yeah,
Correct. ¿Tuvieras que no movimos 2 metros?
So how much
They
would
said
you use that? Just a
one little tiny problem
yeah.
is that we lift up so much fine sediments, and some of it is settling down. So how much is the current?
How much the current?
Yeah, the current.
See on there, the bottom
Here.
road.
It's coming up all the time. It's probably, I don't know, 0.2, 0.3.
0.2, 0.3? Okay. I was saying that we might have some fine gray material from what we lift up on the very first day. Just to tell Becky that if she finds something fine, then something might not be in situ. You know, because we lift up stuff. This cloud, right, is settling down because it's fine, but it's not too fine.
So you ready to go in with this, or?
Yes, if we how far did we move?
Couple meters.
Yeah, yeah. Thank you. You getting any resistance yet?
No.
No.
Alright, open the gate. You're gonna have to give me a live video over there. Just give it like a good solid 5 seconds.
De hecho, que dice de la marca, igual un
Yeah, I guess if we could get this as far as possible then. Not sure what to do about it. Right, sorry if been a bit quiet there while we're discussing plans.
Okay.
And this potential issue with losing material from the bottom of the core. So we're going to see with this Vibra core if we get the same issue again. But you can see that grey sediment that fell out, which is interesting, to be honest. I mean, it's just visually, it looks like the material that we're looking for, in the sense that we'd expect the Chaiten deposits to be a pale grey. When you see them in the delta, they're pumice-dominated sands with a smaller component of dense volcanic rock, including a rock type called obsidian, which is a volcanic glass, quite typical of rhyolite eruptions. So this sort of pale grey sand is quite distinctive in the marine environment. Most of what we're recovering are dark muds, clays, silts, and even actually the sands that we're finding in general are dark coloured, reflecting the local geology. So the pale input from the Chaiten volcanic eruption, this rhyolitic material, is really quite distinctive, and that's quite helpful actually when we're searching for it in the marine sediments and trying to trace its route. So I'm quite interested to see all that material falling out from the Vibra core, even though we don't want it to fall out. It does indicate that at least at the base of this core we're getting into something that's sedimentologically quite different from what we can see at the seabed, and potentially that the Chaiten material was coming south once it entered the marine environment, perhaps carried by the roots of the topography, but also by the currents, with some of that coming into this channel system.
Do you have more resistance here?
It looks like we're vibrating and it's going relatively slowly. So yeah, suggests we do. And we're still only about a metre in, perhaps.
Yeah, we barely started.
So the other thing that's of course informative is the progress of this coring. At the site just adjacent here, but on the high platform next to this channel yesterday, we were pushing in for virtually the entire core length. So it was really very limited resistance, which suggests loose, poorly compacted muds, very easy to push down into. There's clearly a lot of resistance here, which suggests coarser sediment or more compacted sediment. And given what we've seen falling out of that previous core, probably coarse sediment, so sands is what we're getting into. And potentially, if we're seeing that resistance already with only a meter's penetration, these are potentially quite thick sand deposits. And if you overheard my conversation just there with my colleague, Dr. Rodrigo Fernandez from the Universidad de Chile in Santiago, this is what we were just speculating. So we saw on a large scale this the base of this channel has a sort of very large scale ripples, mega ripples, I guess you call them, almost sort of dune-like features, but across the channel, so cutting sort of perpendicular to the channel and going downstream. And those sorts of features are typical of strong currents and built up from relatively coarse sediments. You can't build those sort of structures with muds. You need sands to build those. So we were expecting sands in this sort of rippled channel base, and you know, he was saying how it's surprising that there's all this mud at the seabed. So that mud implies that. So is that as far as you could get in? Yeah. Okay. So that mud implies that at least today there aren't strong currents strong enough to transport sand, because if there were currents strong enough to transport sand, then they would also have transported mud away from this site. So the mud-sized sediment would not be depositing in this area. So we've got sort of two stories here of a system that has created ripples in sandy sediment, but that today is accumulating mud. So we need to give some thought to that, what that means in terms of change through time, in terms of events that have input different types of sediment at different stages in time. But you know, this is exactly what we're here to find out, and this is exactly why we're trying to spread our ROV dive locations into different parts of this system to understand every component of this delta. And it is a complex system, complex topography, complex currents, with feeding from all these different rivers. So it's been quite a challenge to sort of start to piece together the picture. But I feel we are now, with these various sites, really getting enough of an understanding that we can sort of add that marine story to what we know from the subaerial story of the Chaiten eruption. So it'll give a new picture as to how that eruption worked, what its impacts were, how far the sort of footprint was of that eruption. You know, we think of the primary impacts, the ashfall, the lahars, but of course part of that story is, at any island volcano or at any coastal volcano, a big part of that story is where all that material ultimately goes and what impact that has in the ocean and in the marine environment. So I'm just looking out for when the base of the core comes out. I'm interested to see if we're losing this sand from the base again, which we don't want to do. So if we see more evidence of that, we're going to have to think carefully where to store this Vibra core to minimise that loss. We may not want to transfer it onto the rack. We could potentially keep it where it is. There's a little gate just below the Vibra core that sort of closes off the base. That may be an option to try to minimise loss.
I can't really see if it went up or not, but this one I'll commit when I come up. Coming up. Yep, it's coming.
So what you can see now is the Vibra core coming out. Do you get any sense that if we're losing sediment, is it? You not really get that view.
It's hard to even tell if they're out of the ground or not.
Yeah, sure.
Okay, try like, sure.
I guess we could lift them up and then go back down if we need them with the gate closed. that one. If it is leaking, call it daily lamps and try and keep it in position.
There's definitely a lot of viz from right that area, but we can't tell if it's coming from that or just from the general.
Yeah, we can't see the bottom base of it, can we?
I don't think it's all the way out there.
No.
I'm trying to reach out a little more.
Oh, there we are.
That's free?
Yeah.
So you want to try and grab it, or?
Is it possible to lift it any higher than that? Or not really?
Not without re-grabbing.
Okay.
Grab?
Yeah, maybe let's
So you can try and rack it?
grab.
Re-grab. And then you want to try and put it in the rack, see if it leaks again, or?
I think if we see it starting to leak. Oh, wait a minute. Are we seeing stuff coming out of the base there? I think we are, right? Is the gate closed?
No.
There, you see this
Yeah, there's stuff coming out.
stuff coming out. Yeah, could we close the gate and then
Yep.
sort of, is it possible to push down onto the gate? So I think this is a coal catcher issue, isn't it?
That'd be a sediment issue, right? Because
Well-
that's two different core catchers that both have the same result. So it could be because they're the thinner ones.
Yeah, that's
But
what I
it
mean.
would- But it wouldn't be a fault.
Yeah, no, I
It
mean,
wouldn't be a fault.
that's what I mean. This is, yeah.
All right, I'm going to lower down to push on it a little bit. Yep. Okay.
I don't think.
Yeah, she's in the gate there. That's in the gate. Because I can't push down anymore, see? It's slipping. Yeah. So it's getting pushed into that gate. Okay, so now what?
Could we, because I'm concerned we've lost quite a bit, because we could have lost into the hole as well when
Oh,
we're
yeah.
pulling out. Could we get a scoop, please, of the stuff we've lost? So the stuff right in front is the stuff that fell out from the previous one.
Trying to lock this in.
Yep.
If we could sort of minimise the, it's tricky, minimise the amount of mud in there, so just that's useful. Veneer on top. So there's a lot to note there, Manny, that we're into a sort of grey sand, but it's a very loose sort of fluid sand, it seems. It's not holding together. As in when the core was pulling out, the sand's just pouring back out. You know, a bit like an egg tider. Even if that hole's quite small in the core catcher, it just seems to be leaking. Which isn't great, but if we get enough, at least we know what that material is. So we're going to scoop some of it as well from where we lost it, so at least we get a bulk sample of the stuff we lost.
What? Do you want this one?
So that's a sort of, I know it's tricky, but to sort of minimise how much mud we get, we want the stuff that fell out, as we call it.
Just that white area.
Just the white patch there.
That?
Thank you.
If it's easier too, we can grab a scoop from the starboard, pass it.
Yeah, I think you're all right.
I guess some might come up on top of the gates as well, right?
I'm not gonna be able to get in there this week.
Do we need to move back?
No, he's talking about.
Oh, no, I realised, I just, I meant when we recover it, there may still be some sediment there.
Yeah, but it does get washed
get
off
washed
pretty
off.
good, especially
Yeah.
with a current like that. I think we're gonna get a pretty good car wash on the way up.
Okay.
Is this scoop back number 4?
This is, yeah, must be position 4, I think, if it's in that box. Yeah, scoop 4.
Thanks.
So Andy, we don't want to go deep into this. Obviously. So just that sort of stuff we dropped on the surface if possible. So Manny, just to know, this will be mixed. It'll be mixed with surface mud. So we'll, be one we could sieve to try and get that
Do
out.
you want this stuff right here?
Yes, please. Yeah, the sort of grey and white stuff.
It's a good, you don't have to set it.
Oh, perfect, yeah.
Great, looks good. Okay. Yeah, so actually, Manny, we can see it's quite a thin veneer of what we've dropped, but we can definitely see this is much coarser. I think it's one we could sieve out.
Okay.
Yeah. That's great. Thanks. Yeah, it's fine. Yeah. A lot of mud in there to get rid of, but it's also got what we want. Okay, I think. Right, I don't think it's worth another Vibra group, so we're going to have the same issues, I think. So we'll get those up and see what we've got. That'd be useful. So we just collected that scoop bag to sort of recover some of what we're losing, and at least we'll be able to understand what that is. As we've been discussing on previous dives, you never quite know what you're going to find. It's interesting to see such an amount of sand, and I think this looks like this will be our sandiest site actually. Seeing what's dropping out of the base of those Vibra cores, we found many of the sites so far to be really mud dominated, but more so than we were expecting really. And at this site, we've found a route where clearly there's sandier material coming down, and what's interesting is its colour. So I'm quite interested to see that when it gets back on deck, and to identify if that's consistent with the Chaiten source. Because perhaps slightly surprisingly, it would imply that this material had a clear pathway through to the south side of this bay, and to be mixing with the Yelcho outflow channel. So that's an intriguing potential complexity. Yeah, so I think we're good to come back up. Zach.
Good to come
That's,
back up.
yeah, all done. So yeah, that's an interesting complexity, but you never quite know what you're going to find. And I'm suddenly surprised at how loose that sand was, to really see it just falling back out as if it's sort of really uncompacted, very loose material. The aperture in the base of these cores when the core catcher closes is really very small. But it happened with two of the cores, so we're going to have to sort of investigate that and potentially adjust things a little bit. One of the challenges, of course, is you don't really know till you get down there and go into it exactly what the properties of those sediments are going to be. So it's going to be a little bit tricky if we have to adjust the design of our core apertures, core catchers, according to the type of sediment. So something we can look at and think about when we get these back on board. I'm confident we got enough material that we'll at least be able to know what we've got into. I think there will be things preserved in these cores, but the lower parts will be quite disturbed because of that fallout. So, still got plenty of these fish around. We haven't really seen a lot else at this site, except for these plentiful fish.
So, what are we doing with Vibra cores? Are we leaving it?
With the what, sorry? With the Vibra core?
Yeah.
You mean in terms of position?
The second one, yeah.
We're going to leave it there
We're gonna leave it.
because we've closed the gate at the base of it.
Oh, so that piece.
Yeah. Yeah. If that gate's closed, Zach, right? Underneath? Yeah. So close the gate and then pushed it down onto the gate. So it's a stop for the sort of
Bridge, Army.
So the idea there was to avoid moving it and losing stuff when we moved it.
We're coming off bottom.
The fact that we were still sort of leaking when we were moving the first one suggests it's not all falling back out. If that makes sense.
Yeah.
Yeah. You know, if it was leaking, there's still stuff in there. We don't know how much is falling out. Because of course stuff can fall out when it's being extracted. You know, as soon as you're pulling back up, it will have been leaking.
Okay.
Can't be helped.
We'll see once we open it, so.
We will. Yeah, I'm not really sure which one we're going to open here. We'll do what we can. With the scoop, with the core catcher, we'll get something. Yeah.
Sir,
Yeah.
what you say is leaking is like,
Sediment is coming back out to the bottom.
yeah, but like.
Which doesn't normally happen. Yeah, I mean, normally when you remove these cores, you don't see anything coming out of the base because the core capture is designed to hold it in. And that's worked very effectively. In fact, a lot of the cores, you even get a sort of bung of sediment in the core capture underneath. That's not, nothing is holding it in, but it's just, because it's very compacted sediment, it's just stuck there.
We're just
So I've not
popping
seen
off
anything
bottom.
like this, where you pull it back out and literally everything's pouring back through, even though the hole is that big. So that's a
Really?
little surprising,
Okay.
but
Are they doing the tray too?
in a well-sorted sand, it implies it must be well-sorted as well. You know, a sand that can easily flow.
You're welcome.
I can see how that could happen.
Thought it could be a service.
Yeah,
So
we'll
the
see.
current is
It's a bit
definitely
frustrating,
come up a lot.
but there's nothing we can do about
Well,
it.
it's gonna blow us
There's
in
no
a
point
direction
trying. I
away
thought
from
it
the
would
boat.
happen again. I think it's
And
happened
it
twice
looks like
exactly
it's
the same way.
Only in the middle column and not really at the surface. If this is right, so I think we're gonna be all right. So worst case, it'll just, we'll have to drift to get the floats in to operate.
Yes, off bottom. I see there's a comment in the chat about that time we had our salinity super duper low. I'm not sure if you were watching at that time, but we had actually a problem with our salinity sensor on our ROV. Normally, even in freshwater, it doesn't read that low, so we had an issue with the pump into the sensor. So, I will ask for you later if they did find something exciting in those cores, nevertheless, but that salinity reading was actually an artifact. And we are off bottom now, so we're about to recover the ROV. We're about 140 meters from the surface, so it's going to be a super quick ascent. So I appreciate everybody joining the dive today, and it was a bit of a quick one, but hopefully with a fast turnaround we'll be back down soon to gather some more sediment samples at the bottom of this river delta. Cool. All right, take care everybody, and we will see you very soon. Cheers.